So if that's not blinking, you have to tell me because it's still on mute. All right, part 1, part 2. Part 1, how many options? 4. Part 2, how many options? How many sandwiches can I make? Different sandwiches. 12. And we can only do this because I'm choosing one of each type, right? If I'm choosing 2 of each type, I have to do it a different way. Once again, this is a combination because whether you pick the bread first or the salami first or the salami first or the bread second, it doesn't matter, right? You still get the same sandwich. So order doesn't matter. Example 3. A Math 30 quiz consists of 8 multiple choice questions. How many parts of the exam are there? And I don't mean multiple choice, numeric response, written response. How many parts of this multiple choice test are there? How many questions? 8. So each of those is a part. So I'd have 1, 2, 3, 4, 5, 6, 7, 8 parts to this quiz, 8 questions, right? Below it, you could put MC1, 2, 3. So these represent the different multiple choice questions. Then each question is 4 choices, A, B, C, or D. How many different sets of answers are possible? So what would we do? How much would be in each blank? How many options for each one? 4. Now they could make this a bit harder. They could say how many different answers keys are possible technically if the number 1 has to have the answer A. Well, then how many options would there be for number 1? 1, and the rest would have 4. Okay, so they can restrict you to making different questions have different options. But this one was really easy. It's just letting us have 4 options for every single one. Okay, so on an 8-question multiple choice quiz, you're like, oh, the answer key can't have that many options. Yeah, it can. So it's going to be 4, 4, 4, 4, 4, 4, 4, 4. We're going to multiply all of them because it's a fundamental counting principle. But say you forget that. There is a key thing to remember in all of this terms and commas math. And if you say and between them, you're going to multiply. And if you say or between them, you'll add. The key thing to remember is and add have 3 letters and start with A. They do not go together. They're not besties. They're like people who fight. You can't put them together. So and is multiply, or is add. So if you can't remember if you multiply or add between them, it's fundamental counting principle, so we multiply. But say you forget. Are you going to have multiple choice 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 on your test? Or are you going to have multiple choice 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 on your test? Or means you could have this one or this one or this one or this one or this one. Is that how the test works? No, you have to have multiple choice 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. Because you're going to have ands in between all of them, that's why we multiply. That's why the fundamental counting principle multiplies. Now this is the same as 4 to the power of what? 4 to what exponent? 8. Anyone have the answer to 4 to the 8? Put your hand up if you got it. Or 4 times 4 times 4 times 4, same thing. Yeah. 65,536. So if you were banking on getting your 8 multiple choice questions right, because you think you could get the answer key, you'd have a 1 in 65,536 chance. So I wouldn't bank on that. That's why studying is important. Okay? Right? Because you could have, technically, if you think about it, it should be big. Because you could have an answer key where all 8 of them are A's, all 8 of them are B's, all 8 of them are C's, all 8 of them are D's. Now, you could have an answer key with 7 of them are A's, and the 8th one's B. Or 7 of them are A's, and the 8th one's C. Or 7 of them are A's, and the 8th one's D. or 6 of them are A's. Like, there's a lot of answers, different types of answer keys, right? So people think when they see this, they're like, oh, that's too many. It's actually not. There's a ton of different answer keys you could make, right? Okay. Now, those ones were easy because there was no restrictions. Now we're hitting ones with restrictions. Fundamental counting principle involving restrictions. Restrictions means, like when I said to that question, the first question, the answer has to be A. If I did that, there would be a restriction, right? It's not open that they're all the same. When solving problems involving restrictions, you must deal with the restriction first. You must. Anything that doesn't have a restriction, you deal with last. Anything with a restriction, you deal with first. So on that question, if I said multiple choice 1 had to be A, I would have to put a 1 in that blank, because that's all the options there are for that one, and then I could do the rest. But I have to deal with the restriction first. Okay? So let's look at the first one. Example 4. In a second. Okay. So in how many ways can 5 different, this is huge, different models? The reason why 5 different models makes a difference is because if they were the same model and they were all black cars, could you tell the difference between them? So if you lined up 5 cars that were the exact same model of car, and I told you to cover your eyes and cover your ears so you couldn't see what I was doing, and I moved all 5 around and put them back in the exact same spots, would you tell me I moved them? No, you wouldn't be able to tell, right? But if they're 5 different models, so one's a truck, one's a car, one's a minivan, and they're the exact same black, but I tell you close your eyes and cover your ears, and I move them, will you be able to tell I moved them? Yeah, they look totally different. Yay, they're black. Who really cares? They look totally different. Okay? So 5 different models of black cars and 4 different models of red cars can be parked next to each other in a parking garage. So how many cars are we parking? 9. We're parking 9 cars. 5 black, 4 red, totally different looking cars. Okay, might not even be the same shade of red or black. Who really cares? It is different though. If this was 5 of the same models, questions totally change, which we'll get to when we do repetitions. Okay, park next to each other in a parking garage. If a black car has to be first, so there's my restriction. I have to have a black car first and a red car last. So I'm going to park 9 cars. So I'm going to park them so you can see me parking 9 cars. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9 spots. Right? Before I would just put the first blank, I had 9 cars to park there, right? That was what I would normally do. But this one has restrictions, so I have to do the restrictions first. I have to have a black car in the first spot. And I have to have a red car in the last spot. So those ones have to be dealt with first, because restrictions have to be dealt with first. Okay? If there was no restrictions, I'd park 9 cars, and I couldn't park 9 in the one spot. That would be really, I'd stack them. That's really strange. I would have 9 options of cars to park here, and I'd leave one there, correct? And then I would have how many now? 8, and I'd leave one there, correct? Now I'm 2 are gone. So 7, leave one there. 6, 5, 4, 3, 2, and then I'd have one little car left to put there, correct? So if there was no restrictions, it would just be 9, 8, 7, 6, 5, 4, 3, 2, 1, because I was leaving cars behind, correct? But there's restrictions now. So the first one, it has to be a black car. So do I have actually 9 options of cars to park in that spot? How many do I have? 5. So down here is where I list my options. Up here is how many there actually are. So up here goes my numbers. So I have 5 different cars that could park there. Do I actually park 5 in that spot? No, I'd have to stack the cars on top of each other. That's just not a good idea. It'd be dangerous. Okay? So I'm not actually parking 5 there. I have 5 options. And how many did I leave there? 1 car. It's 1 parking spot. Okay? Then I go to the red spot. How many options do I have for this one? 4. I have 4 options for that spot, but how many cars am I leaving there? 1. How many cars have I used up? How many cars are currently parked? 2. So how many do I have left? 7. Do I care if they're black or red now? No, because there's no stipulation on what color goes in the middle, right? So I have 7 cars left. I always start left to right after I'm done my restrictions. So I have 7 cars left for this spot. Then I park how many there? 1. Now how many cars do I have parked? 3. So how many do I have left for the next blank? 6. Then 5 for this one. Then I park it 1. 4 for this one. I park 1 there. 3, park 1 there. 2, park 1 there. 1. Make sense? So the above options are not how many cars are parked in that spot. It's how many options. I'm only parking 1 car there. That's how many options are there. You have to wrap your head around that. That's the hardest part of this. Okay? On the top is the number of options I have for that parking spot. Okay? Now, am I parking this car and 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 this car? Or am I parking this car or this car or this car or this car? Is it and or? It's and, because I'm parking this car and this car and this car and this car. If I was parking this car or this car, that would mean maybe I park this one, or maybe I park this one, or maybe I park this one, or maybe I park this one. Like, you're not parking all of them. Okay? So it's and. It's also fundamental counting principle. So whenever it's these blanks, you multiply. Now, it sucks, but it's not the worst thing in the world to have to go 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 4. Not the worst thing in the world, but kind of crappy. There's got to be a better way. So 5 and 4, I'm going to put together because they don't run in a pattern, right? So 5 times 4 is 20. So I'm going to do 20, and then I'm going to multiply it by 7 times 6 times 5, right? I don't want to do that. I don't want to go 7 times 6 times 5 times 4 times 3 times 2 times 1. But if I have a number that runs down by ones all the way to 1, so 7 times 6 times 5 times 4 times 3 times 2 times 1, I can represent that by 7 factorial symbol. It's an exclamation mark. So I can go 7 factorial. Okay? I can only do it with the 7 because the 5 and the 4 don't go down to 1, do they? I don't go 5 times 4 times 3 times 2 times 1, do I? I just go 5 times 4. So I have to represent that with 20. But I go from 7 all the way to 1, so I can go 7 factorial. Okay? So on your calculator, what you're going to do is you're going to go 20 times, on your main screen, 20 times 7. And how you get the factorial symbol is you press math, an arrow to the left, so it hooks you up with the probability. So you're going to go to probability. If you have the fancy new calculators, you have to hit left twice. And then it's number 4. So you're going to go 20 times 7, math, and I only have to arrow over once, but if you have the fancy ones that are colored, you have to arrow over twice to get the probability. So PRB, and you pick number 4. So there's 100,800 ways that I could rearrange these 9 cars with a black car at the front and a red car at the back. So if you're someone who thinks you're going to list all the options, you're probably going to miss 1 or 2 or a few thousand of them, okay? And you're not going to finish the test. So you have to know how to do your question. All right? Could you have went 5 times 7 times 6 and done it that way? Absolutely, you would get the same answer. But sometimes they'll list the answer like this as one of the multiple choice options. Okay? Could you turn this into an answer and turn that into an answer and match them? Absolutely. Okay? So we're going to look at the next one. Eric has been assigned the task of determining how many odd 4-digit numbers there are. How can you tell if a number is odd? 2, 4, 6, or 8's your evens. 1, 3, 5, 7, and 9 are your odds. But how can you tell if a number is actually odd? So say I give you 25. What is it? Odd. 26. 27. 28. What am I changing? The last number, the last digit. So in order for a number to be odd, the last digit has to be odd. I don't care what the rest of the digits are. The last digit has to be odd. I didn't change the 2, right? But you knew it was still odd. So odd means last digit must be odd. They're not going to say a 4-digit number where the last digit has to be odd. They're not going to say that. They're going to say an odd 4-digit number, and you need to know that when it says odd or even, that your last digit needs to be odd or even in order for that number to be odd or even. Okay? So the last digit. Now it says 4-digit number. What the heck is a 4-digit number? What's an example of a 4-digit number? 1, 2, 3, 4, so 1,234 is a 4-digit number. 2,000 is a 4-digit number. 1,500, 4-digit number. Is 0, 1, 2, 3 a 4-digit number? No, that's $123 disguised as $1,000, okay? And you'll be like, well, it's okay. No, if that was your pay, you'd be like, no, you're not paying me in a 4-digit number. That is a 3-digit number with a 0 in front, you liars. That's what you would say, right? So it's not okay. If you think about it in money-wise, 0, 1, 2, 3, they're paying you $123. They're not paying you a 4-digit number, which would be great if they paid you a 4-digit number. Okay? So if it says 4-digit number, if they say that, they're indirectly telling you the first digit can't be 0. If the first digit was 0, would it be a 4-digit number? No, it would be a 3-digit number disguised as a 4-digit number. So if they say 4-digit number, that's telling you first digit can't be 0. 3-digit number, 2-digit number, 10-digit number, it doesn't matter how many digits it is. The first digit cannot be 0, or it wouldn't be a 4-digit number, or a 3-digit number, or a 2-digit number. It would be a 3-digit disguised as a 4, or a 5-digit disguised as a 6. Okay? So that's the key thing if it says digits. So this is being nice. They won't do this on the diploma. He has been told that a digit such as 5,267 is a 4-digit number, whereas 0,267 is classified as a 3. They're not going to tell you that. I just put that in there to tell you that. If they say 4-digit number, they're meaning the first number can't be 0. Okay? Now, does it say anything about repetition? The numbers can repeat or they can't repeat. What does that mean? Like the number 1111. That's all ones repeating, correct? Does it say in here that I can't repeat? No. If it doesn't say you can't repeat, you assume you can. Okay? They'll never say you can repeat. You can repeat all the numbers. They're not going to say that. The way they tell you that you can repeat all the numbers is they don't tell you you can't. Okay? So if it doesn't say you cannot repeat numbers, you assume you can. All right? So we can repeat numbers. So we have a 4-digit number. 1, 2, 3, 4. We have how many restrictions on this? We have a restriction on the back number because it has to be odd, the last digit. We have a restriction on the first digit because it can't be 0. Below, I'm going to list all of my options. Above, I'm going to tell the number of options there are. Okay? Now, we have to deal with our restrictions first because we always do. So, I'm going to deal with the back number first. You can deal with the first or the last. It doesn't matter because those are where my restrictions are. Okay? So, my last digit, how many options can I have? 5. What numbers? 1, 3, 5, 7, 9. Why can't I have 11 in that blank? 11 is not a single digit. 11 is a double digit. It would take up 2 blanks, right? We can only take up the 1 blank. So we have to stop it. Our only options we have in these blanks are 0 to 9. They're not going to tell you that, but those are the only options because after that, it's no longer a single digit. It would have to take up 2 blanks. Okay? So our options are 0 to 9. The only options of 0 to 9 that are odd are 1, 3, 5, 7, and 9. So we have to have those 5 to make up our last blank. Now, we don't have to keep a number there because we can repeat. So in the first blank, what are our options? Everything but 0. So we actually have 1 to 9. 1 to 9. How many numbers is 1 to 9? 9. 0 to 9 is 10. If you do not know, rather than getting it wrong on the diploma, I want to see fingers. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is not embarrassing. Getting it wrong is embarrassing. Okay? This, not embarrassing. Saying 1 to 9 is 8, that's embarrassing. Use your fingers if you have to. I do not care, as long as you get it right. You can hide them under your desk, or you can freely show that you're doing your fingers. I don't really care. So 1 to 9 is 9. Now, the two middle blanks, do I have any restrictions on those? So it could be the numbers from what? 0 to 9, both of them. How many options is 0 to 9? One more than 1 to 9. So how many options? 10. Now some people will fight me and they'll say, you told me I can't have a 2-digit number in that blank. Am I putting the number 10 in that blank? No. Remember, I struggled with this in high school so badly. I wanted above the blank to be what number I picked. That's not what it is. Above the blank is not the numbers you're picking, it's how many options you have to put in there, right? Below are the options, above is how many of them there are. So is this number 9, 10, 10, 5? Is that the number I'm making in the end? No. The number I'm making in the end could be 1001, 1003, 1005. The options are on the bottom. How many of them are on the top? Okay? So what's 9 times 10 times 10 times 5? 4,500. So there are 4,500 odd 4-digit numbers in the world. Okay? Now B. B is where it gets a little bit trickier. B says, Eric has now been assigned the task of how many odd 4-digit numbers, so that stays the same. 1, 2, 3, 4. Odd 4-digit numbers there are, but the difference here is can't repeat. No repetition. Okay? No repetition. So we still deal with our restrictions first, but now we're going to pretend to keep a number there because the number has to stay and it can't happen in any of the other blanks. Okay? So what options do I have for the last blank? 1, 3, 5, 7, 9. Did that change? No. The difference is yes, I still have 5 options for this blank, but what's going to happen? One of those numbers we're going to pretend stays there because I can't repeat it. So if it was a 1 at the back, I can no longer use 1 for the other 3 blanks, right? If it was a 3 and in a 3, I can no longer have 3 for the other blanks, okay? So I'm just going to pick one of them and pretend to keep it there. So which one do we want to keep? 1, 3, 5, 7, or 9? Doesn't matter. Pick one. 9? Sure. You guys are so helpful. So I'm going to keep a 9 and I'm going to circle it and I'm going to pretend that I kept 9. Could you have kept 3? Sure. Could you have kept 5? Sure. 7, whatever. It doesn't matter. All that matters is when you go to list the different numbers you can have in the next blank at the beginning, because that's the next one we have to go to, you won't list 9. If you circle 3, you won't list 3. If you circle 5, you won't list 5. It doesn't matter which one you pick. Just circle 1. So when it says no repetitions, I always circle them and keep it there. So now for the first blank, instead of having the options of 1 to 9, I actually only have 1 to 8. Correct? Because I've used up 9 already. I can't use 0 because then it wouldn't be a 4-digit number. So how many do I have now? 8. This is where people fall. So I'm going to keep 8 because I'm lazy and it's easier to write the options down if I just keep 8. This is where people falter. So what options do I have for the second blank? 1, 2, 7, but also 0 because I haven't used it. I didn't have it as an option in the last blank or the first blank. Didn't have it for the last blank because it's not an odd number. Didn't have it for the first blank because I can't use it. So you have to remember to bring that 0 back because now I actually do have an option. So 0 and then 1 to 7. How many is that? 8. How many are you going to put? 7. What are they going to have the answer on the diploma to? 7. Every single answer on your diploma is a common error. They're worked out. When we write the questions for the diploma, when I go up to Edmonton, we write the questions. You have to give the correct answer, and then your last 3 answers are common errors, and you have to explain why. So you give the 3 answers, and then you have to explain in the little box beside how they're going to error to get that answer. So nothing on there is random. So if you don't know your stuff well, your common error will be there. So you need to know your stuff backwards and forwards. Okay? So the 8765 answer will be there if you forget to put the 0 back. Okay. I'm going to keep the 0 because I think it'll be easiest to keep. Then 1 to 7 goes here, and now I have 7. What's 8 times 8 times 7 times 5? Put your hand up or I'm going to pick on you. If you have it. 8 times 8 times 7 times 5. Yeah. Thanks. So just doing the restriction of no repeating digits, I went from 4,500 odd numbers to 2,240 odd numbers. They could ask you on a diploma this question combined. They could say the old code to whatever was odd 4-digit numbers. The new code is odd 4-digit numbers, no repetition. What's the difference? And make you find the difference between them and actually subtract them. They could do that, right? You need to know your stuff. Example 6. Car number plates in an African country consists of a letter other than I or O. So I'm just going to start writing my restrictions. So I can't have I or O. And put slashes through them. How many letters are there in the alphabet? 26. How many vowels are there? A, E, I, O, U. 5. There's never a sometimes Y. Please don't. They just won't. On the math, they will never. There's no sometimes Y. A, E, I, O, U. So there's 5. 5 vowels, 26 letters. What's the opposite of a vowel? Consonant. A lot of you don't even know that word. Shocks me. Consonant is the opposite of a vowel. So if there's 26 letters in the alphabet and there's 5 of them that are vowels, 5 away from 26 is 21 consonants. Consonants. Constant is the number at the back of an equation that doesn't have a variable. Consonant is not a vowel. Consonant. Constant. They're not the same thing. Consonant is not a vowel. Constant is the number without a variable. Okay? All right. So we have I and O cannot be. Followed by 3 digits. The first cannot be 0. Does do any stipulation on these 2? No. We have no restrictions on those. Followed by any 2 letters which are not repeated. And these 2 letters have no basis on this one. So if this was a diploma question, they'd have to say the back 2 letters do not affect, have no basis based on the first letter. These 2 is standalone. Okay, so I don't really care what letter this is. These 2 just can't be repeated. Okay, they'd have to do this question. I feel like is vague, so they'd have to make it more specific. Okay, how many different car number plates can be produced? So if you deal with restrictions, this is a restriction, this is a restriction, and these 2 back ones actually have restrictions, do they not? They just can't repeat. Do the 2 middle blanks have any restrictions? Does it say that the digits can't repeat? So they're fair game. They can repeat all you want. Okay? So the only restriction on the first blank is it can't be I or O. How many letters left? 24. The next one is it can't be 0. So I have the digits 1 to 9 open. How many is that? 9. I'm going to go to the back 2 because the middle 2 don't have any restrictions, right? I'm going to do those last. The back 2 say that they just can't repeat. So I have A to Z. How many letters is that? 26. And then they can't repeat. So when it says can't repeat, I always hold 1. I'm going to hold the Z. So now I have A to Y. How many options? 25. And then your middle blanks. You have 0 to 9, right? So how many is that? 10. Once you get good at this, a lot of people don't write these ones down. The options underneath, that's fine. What extremely large number is this? 24 times 9 times 10 times 10 times 26 times 25. Yeah. 14,040,000. So that's a lot of license plates, right? Now, in Alberta, we've changed the license plates, correct? They've added an extra letter, I think. Did they add an extra? It's an extra letter, or is it an extra number? Extra number. It's like, yeah. It's 3 letters, 4 numbers. Yeah. The reason why they did that is they realized that they were starting to run out of license plates. The catch on the Alberta license plate is if you actually Googled it. There are restrictions on what certain things can be on it. But they were realizing that they were starting to run out, so they added an extra number. What does that do? That adds an extra 0. So let's say previously the options they had was, say, 100,000, right? If you add an extra 0 onto that, you might think, oh, that's not very much. An extra 0 on 100,000 is what? 1 million. It's actually 900,000 extra options, right? So just adding a digit added a whole bunch more license plates. And that's why they did that with, they added a new, instead of 403, they added 587, right? That opens a whole nother amount of phone numbers that they can use because that gives them an extra set in front, an extra blank, right? Makes a big difference. Alrighty. Now this question is a pathways question. You might say, where the heck does this fit in any of this? Well, you can actually use fundamental counting principle to get this, but if you were really stuck, you could count the pathways. So James wants to travel from Pitland to St. Luke's. How many different routes from Pitland to St. Luke's? Now you're not going to backtrack. You're not going to like start circling like Pitland to this Q place, back to Pitland, back to Q, then to Pitland, then to Q, then to S. Like you're not going to like circle it. You know, you're going to just get there. So they don't have to say that you're only going from Pitland to St. Luke's and not backtracking. They could, but they really shouldn't have to. So how many ways could you do it? Well, this would be 1, then 2, then 3, then 4, then 5, then 6. So this top one here, I have 6 options, right? I counted them all. The bottom one here, I have 1, 2, 3. So I have 6 paths on the top, 3 on the bottom. Would I multiply them or add them? You'd add them because you're not doing these paths and these paths to get there. That would mean you took every single path to get there, which makes no sense. You're doing these paths or these paths, correct? You're going to take either these ones or these ones to get you there. So you add them. Now, is there any way through a fundamental counting principle you think we could do this? How on the top could you get 6? The first part has how many? From P to Q. The first part from P to Q has 2. The second part from Q to S has 3. What do we do when we have more than one part? Multiply them because it's fundamental counting principle. So you could go 2 times 3 equals 6. Now, why would we multiply them? Because it's fundamental counting principle. But if you forgot that, you're taking these paths and these paths to get you to here. Okay, this one, this part has how many paths? 3. This part has how many paths? 1. Multiply them because it's parts to get you a whole. 6 and 3 is 9. Okay? We'll go through these ones and then we'll be done. Example 8. The telephone numbers allocated to subscribers in rural area consists of the following. The digits 3, 4, 5 followed by any 3 digits. The options I have for this one are 3, 4, and 5. That's it, right? So how many options do I have for the first blank? 1. It's the number 3. How many options for the second blank? 1. It's number 4. How many options for this one? 1. Do any restrictions on those last 3 ones, like they can't repeat, or one has to end in a 5, or has to be odd, or anything? No. So what options do I have when there's no restrictions on it? 10, because I have 0 to 9. So I have 1,000 options for my first option. So the digits 3, 4, 5 followed by any 3 further digits. Or means what? Add. So we're going to add the next one to it. The digit 2, not 2 digits, the digit 2, followed by one of the digits 1 to 5, followed by any 3 further digits. So what's the stipulation on the last 3 blanks? There isn't one. So it's 5,000. How many different telephone numbers are possible? 6,000. Yeah. We're actually going to start with the even one tomorrow because it's harder than the odd. The 5,000, my numbers just suck. Okay. There we go.